This is section 9.1, domain and range. Tonight's homework is page 577. Excuse me, Mina. Numbers 15 through 20. I'm going to do our notes real quick and then we'll go over the second part of the warm-up. So as a review, domain is in relation to your x values, or which we call the input. And your range is in relation to your y values, which we call the output. So let's imagine you're looking at your graphing calculator, or let's imagine that you're graphing something. Here's your screen. Here's your Cartesian plane. And here's your graph. So all too familiar graph of a parabola. And if I asked you to describe to me the domain and the range, I'm going to give you a very simple way to remember. Let's talk about range first. Range is actually a little bit easier to solidify because once we get the range down, I think domain is actually easier to understand. These are words we've heard before. And from what I see from some of your summaries and reflections, words you don't really like. You kind of don't see the need, or you haven't really found the efficacy in using domain and range, and so I'm hoping that changes today. So your range, I want you to imagine that this is an elevator of a building. Everybody with me? So here you are, you're walking into the front of a huge building, upstairs to go up the building, and downstairs to go to parking. Everybody with me? So the range is going to describe anywhere that there's action on any of the floors. So pretend the red, or the graph, describes where people are. People in the building. So if I ask you to describe what is the range of your building, what you're going to tell me, Josh, I need you, babe. What you're going to tell me is what buildings are there people, where is your graph existing from up and down. That's my range. So I want you to imagine that you're standing in this building, go up the elevator, you step out of the elevator, you look left, look right, you're like, yep, there's people here. Because if you look to the left, there's people here, and there's to the right, there's people here. Everybody with me? So the elevator serves as your gauge to decide if there's action. So is there somebody on this floor? Yes or no? Yes. Why? Because is there somebody to the left and to the right? Yeah. Is there somebody on this floor? How about here? How about here? How about up here? How about up here?
No.
What do these arrows mean?
Keep going.
It does keep going. So how about up here? How about here? How about up here? Okay. How about here? How about here? How about here? No. So your range pretty much ends at what floor? The -2 floor. So if you were like to go down 2 floors from the basement. Everybody with me? So the way you would describe the range is all numbers bigger than -2. Everybody with me? It's not always bigger because it exists bigger. If it had flipped down, it would be all the numbers smaller than -2. It's just where all the action is. So the action's at -2, at -1, at 0, so on and so forth, and those are all the y's that are greater than -2. So far, so good on range. Yes, sweetheart. So I'm going to show you right now how to write that. But the way you say it is y is greater than or equal to -2. But I'm going to show you how to write. All right, now let's talk about domain. If the range is going up and down the y-axis, what do you think is going to happen with the domain? The same thing, except across the x-axis. What's your question, Sarah? Did you have a question? Okay. All right, so this time for domain, I want you to imagine that you're walking, la 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 la. You're walking across the x-axis. And it's going to be your job to decide if there's action. So it's a little bit different this time because you're not inside of a building. I want you to imagine that you're like on an open field and you're looking through. Have you guys ever been to those museums that you can look down and there's like the plant life under you? Have you ever seen those before? They have like the water under you, and you never seen those? I went to a wedding one time. It was kind of creepy. The dance floor was on top of a fish tank. So when you were dancing, you were dancing on water and you had these big old heels. So I was like, I'll be over here. I'll dance for you. But anyways, when you look down, it's like you can see all the animals. You guys have never seen this before? Okay. So I want you to imagine that you're walking across here. And remember, there's arrows here. These arrows mean that they're going to continue on forever and ever and ever and ever and ever. Okay? A lot of us think that this means this. No, it means this. Everybody see that? Y'all with me? So, if you're standing on an empty field and you look up to see any action, let's see, you're looking for any type of bird or any type of animal that's flying by. That's what I mean by action. Is your function true at that point? Or is your function existing at this point? And some people here will say no. But why is the function actually existing when you're standing here? Alyssa? Yeah, because it continues infinitely. Right? So it might be freaking far, but it's there. Are you guys with me? Does the function exist over here? Yes or no?
Yes.
Yeah, because the arrow continues. How about right here?
Yes.
How about over here?
Yes.
Yeah, right under you. Right? It's like you can look down and be like, oh my god, I can see fish. Right? How about right here?
Yes.
Yeah, right there. How about right here? How about here? How about here? How about over here?
Yes.
Right? So the domain, is there any part that you can walk along the line and not see action?
No.
So it's all real numbers. The domain is everywhere. There's no asymptotes. There's nothing telling me there's a break. There's no electric fence. It's just all real numbers. Who feels better about domain and range now? Good. All right. So what we're going to do today is we're going to describe our domain and range of our rational functions. So how would you write this? For this example here, you would say the domain is all real numbers, and that the range is all real numbers except, I'm sorry, not all real numbers. Y has to be greater than or equal to -2. That's how you would describe this one. All right, let's do an example. Here we go. Example 1. Last night's graphs, you had some simple asymptotes. Let's say you have one here at 2. And then you have a graph like this. Remember, our graphs are always going to lean towards the asymptotes. I'm just going to go ahead and highlight this asymptote. And there's definitely one here because they're not crossing that axis. All right, let's see domain. Is domain the one where you walk across the field or the up and down the elevator? Walk across the field. All right. The way I remembered at your age, domain means like walk the main floor, like main. walk across. Hey, it worked for me, and I have 3 degrees. I'm just saying. If you want to use it, you can. Otherwise, just remember it. Ready? If I'm standing right here, is there action either above me or below me? Remember, there's an arrow here, so what does that mean? It continues, right? So how about over here? Is there action? How about here? Down here? How about right here? How about right at 2? No, there is no action because it's an asymptote. I don't see any orange, do you? Everybody with me? So the domain has a break right here. The domain is not allowed to be what number? 2, because it's an asymptote. How about 3? 4? 20? 100? All right, so it can be everything besides 2. So the domain is all real numbers except we're going to say x cannot equal 2. Now on your test, it could be written like this. And I have to make sure you know how to write it in function notation, which is negative infinity to 2, and then 2 to infinity. These little parentheses means you have to skip 2. So that's how you write the domain. Yes, honey? You can just do this. All real x cannot equal 2. Yes, honey? I will accept either way, but because it's multiple choice, I need you to be able to read it both ways. Because it might be written like this, and it could be written like this. So you have to know what it means. Okay? How would you write the range? Ready? Range means going up and down the elevator. You guys with me? Is there somebody on this like -3 floor? There's orange right there, right? So if you stepped out, there's somebody right there. Sure. Sure. How about -2? How about -1? How about 0? Is there anybody on the main floor? There's no orange here, right? There's no orange there, right? So my range, that's okay, babe. My range does not include 0. So how do I tell people that the range is everything besides 0? How would you say that? All reals except. But what letter do I use this time? Do I still use x? Y cannot equal 0. How would I write that in notation? How would you write it like this? Negative infinity to 0, and then pick it back up at 0 to infinity. God bless you. Yes, honey. Sure. All right, let's try another one. Example 2. I'm going to throw a little bit more of a complicated graph at you. Looks like there's a lot more action here. Let's talk a little bit about our domain here. Domain means I go up and down the elevator, or Walk across the x-axis. Okay, let's walk across the x-axis. Is there action at -3, -4? How about at -2? No. Where else is there no action? 4. These are your two what? What are they called? What kind of asymptotes? Vertical asymptotes. So these are your two vertical asymptotes. So I'm starting to realize I don't really have to graph things to figure out what the domain is. Because if I know my vertical asymptotes, I know what my domain is. That was last night's homework, or the night before last. Remember I gave you that chart? And you had to tell me what the domain and the range were? This is how we made the connection now. Now you see the asymptote tells you where the domain does not exist. So how would you tell people the domain does not exist at -2 or -4? Can we do the function notation first? Ready? Negative infinity to what? To -2. Pick it back up at -2. Be careful. Don't forget the middle part. -2 to, careful, to 4, because it's not through the 4, right? And then 4 to infinity. Make a side note to yourself, you guys. You're not allowed to use these. It has to be parentheses, not brackets. You're not allowed to use these because these means that you're allowed to include the 4. This means including 4. Hello, the whole point is for you to tell people not to include 4. So this is not allowed because this means including, and you don't want to include. You want excluding. That's what these parentheses are for. So on the test, I have an answer that looks like this, and not to be mean, but I have another answer, and the little brackets are there. And I'm going to see if you fall for it. It's not brackets, it's parentheses. Yes, honey? Yes, that's exactly what I was going to show you right now. I was going to show you the function notation for the original equation. All right, what is the range for this bad boy? Go up and down the elevator, right? Is there anything off limits? Zero? I see something right here at 0. Is there anything that, any floor that doesn't have action? So how do you tell people that your range is everything? All real numbers, good. So the way you say it in function notation is negative infinity to infinity. Now, this is what I wanted to go back for your doyo. How would you write this in function notation? How do you say all real numbers in function notation again? Okay, so let's do that. That's going to be negative infinity to infinity. How would you tell people that y is greater than or equal to -2? Instead of parentheses, what are you going to use? Brackets. So this time you're going to say, all right, you're allowed to use -2. It's cool. You can touch the -2 to infinity. Oh, I think I just lost people. 10 seconds in your group. Can you make sure everybody in your group understands why that's a bracket, not a parenthesis? Talk to each other. Mia, make sure your group.
So whenever it's infinity, right, you have to naturally
Make sure Isaiah gets it.
keep going on here.
All right, here's your doyo. Sorry, guys. Give me the domain and range, please. All right, any questions on the doya? All right, let's go back to our number 2 from the warm-up. Let's see how much we were able to do on our own. I'm going to ask some people to help me out because we are short on time today for the rally schedule. So I have f of x is equal to 2x squared plus 2x over x squared minus x minus 2. The vertical asymptotes are set equal to the denominator equal to 0, so x squared minus x minus 2, and that factors to x minus 2 and x plus 1. I'm going to set that equal to 0, so my asymptotes are 2 and negative 1. What's the domain for this? Negative infinity to negative 1, negative 1 to 2, and then 2 to infinity. Be careful. So you have to start with a positive number. All right, so this bad boy right here is going to factor to, God bless you, x minus 2 and x plus 1. So I should always factor it because I'm going to end up plugging stuff in. Dylan, are you okay, sweetie? All right, so x-intercepts are going to be when the numerator is equal to 0. So that's 2x squared plus 2x equaling 0. I can factor out a 2x, and I'm left with x plus 1. So my x-intercepts, God bless you, are x equals 0 and x equals negative 1. So this top part factors to 2x and x plus 1. What do you notice is going to happen here? There's a hole. Look, negative 1, negative 1, negative 1, negative 1, x plus 1, x plus 1. So there's going to be a hole at x equals negative 1. Is this top heavy, bottom heavy, or the same? The same. What do you do when you are the same? Just look at the coefficient. What's the coefficient of the x squared here? 2. What's the coefficient here? What's 2 divided by 1? 2. So my horizontal asymptote is y is equal to 2. Now I just make my table. I have my two asymptotes, which are 2 and negative 1. There's actually going to be a hole at negative 1. So that means it's going to have the audacity to pass through it. That means I need to make sure I plug it in and see what I get. So here I have 3 points, and then a negative 1, and then 3 points, and then I want my 2, and then 3 points after that. So the point before the negative 1 is 0, and then, negative 2, and then negative 3. This should be 0, 1, and then goes to 2. So this is 3 and 4 and 5. What happens when you plug in 0 if it's an x-intercept again? Yeah, because this is 0, 0, and this is 0, negative 1. I'm sorry, negative 1, 0. So what happens when you plug in 0? You get 0. What happens when you plug in negative 1? You also get 0. But it's actually a hole, so that's why this is going to get fixed right now. So we'll get back to this. All right, what'd y'all get when you plugged in 1? Okay, I want to recommend something, and I want to actually survey you first. When you plug it in, Isaiah, don't let me lose you, babe. When you plugged it in, you could either plug it into the original equation or plug it into its factored form. Raise your hand if you plugged it into the original. Raise your hand if you plugged it into the factored form. Okay, the factored form is going to give you less error. Trust me. Okay, I'm not saying you can't do it, but I'm saying when you plug in 1, yeah, no problem. But throw in a negative in here, and some of you guys will make typographical mistakes on your calculator. Kyle, are you with me? So when we plug in 1, let me try plugging it in here. What's 1 plus 1? 2. And then what's 2 times 1? 2. So 2 times 2 is 4. So on the top you have 4, right? That's if you plug in 1. What's 1 minus 2? Negative 1, what's 1 plus 1? 2, what's 2 times negative 1? Negative 2, so what's 4 divided by negative 2? Negative 2, so we can plug it in, and we get 1 gives me a negative 2. What happens at 2? It's undefined. Alright, now let's see what happens at this hole. Remember Miss Riad told me yesterday. Duh, if you plug in negative 1, it's undefined. That's why we know it's a hole. So you have to plug it in without the negative 1 part. You just plug negative 1 into here for the hole. Everybody with me? So plug negative 1 in here. What's 2 times negative 1? Negative 2. What's negative 1 minus 2? Negative 3. What's negative 2 divided by negative 3? Hello? What's negative 2 divided by negative 3? Lauren! Positive 2/3. Very good. So this is not 0 now, it's positive 2/3. And there's a hole there. Mina, what'd your group get for 3, 4, and 5? Guys, I told you guys that this would be the part that you guys will struggle with. I don't know why, but we do need to be much more masterful at this. Can you guys help me out, Deshaun? Did you guys get 3, 4, or 5? Oh, no, this was the warm-up. This was the warm-up. Who's got some numbers for me? What you got, babe?
6, 4, and then 10 over 3.
This one?
That's 6, 4, 10 over 3.
Dylan, is that what you got? All right, did you guys get negative 2 and negative 3? What'd you get, Dylan?
Got 6 over 5 for negative 3.
Is that what you got?
Yeah.
6 over 5 here. And
No,
then,
for negative 3.
I'm sorry?
For negative 3.
You got 6/5 for negative 3? Excuse me. And then did you guys plug in negative 2?
Got 1.
1? All right, now we just have to plot these points, guys. Take a minute and plot these points for me so I can show you what the graph looks like. Did you plot it already?
Yeah.
Okay, I'm gonna show it. Just make sure it's highlighted, the asymptotes. Deshaun, can you get ready for the C high, please? I know. We can only try our best. Hopefully you have something that looks like this. Remember that there's a hole at negative 1. And it's at 2/3, so you should literally have a hole in your graph. You should not have a line. So it's just like this. Draw a hole, and then it continues. And then on this side, it goes like this, leaning towards the asymptotes. Notice that there's a horizontal asymptote here at y equals 2. You have 2 verticals, but then that vertical is no longer existing because now it's a hole.